Hello and welcome to another tutorial. So this time we are going to be making a system to allow us to flip between worlds. So the inspiration for this is based upon a section of the game Dishonored 2. So if you haven't played the game, some mild spoilers, there is a section in that game where you have an item and that item allows you to switch between two different versions of the environment you're in, a present day and a past version. And as well as allowing you to switch between them, it also allows you to peer from one into the other. So that's what we're going to set up. We're going to set up that ability to actually switch between ones and also the ability to peer into one point in time and space from a different one. So let's dive on in. So what I have set up is two different versions of a room. One has a intentionally different colored floor to the other. There's also some additional obstacles in one versus the other and a couple of other minor sort of layout changes there intentionally so that we want to make it so that if we try to switch between realities, that we can't do that when that would result in us ending up inside a box, for example. So let's get started with this. There's a lot of different pieces that we need to build for it, but the starting point is really going to be that being able to switch between worlds. So we need something that's keeping track of that for us. So what I'm going to do is I'm going to create a setup here, and I'm going to call this, for want of a better term, Reality Manager. It's kind of flipping between different realities, so we'll go with that. So, okay, I'm going to have a Reality Manager, so that's going to be the thing that will kind of keep everything in sync, manage the transitions, all of that aspect is what it's going to handle. So we'll create our object for it. And the first thing we really want to be able to do is just have it that it's keeping track of our two environments and being able to have some object move in the other environment. So let's add our reality manager onto it. So it's going to need to be able to track the player. That's going to be a really important thing. So it's going to need a couple of things here. So it's going to need to be able to know. Now we could give it the full character mode. Might actually be useful to do. So this will be our tracked player. Now the character motor, we can't directly access the camera from that. That's in the player character motor. So I will actually have as a separate thing the tracked player camera. So one of the things that we're going to need to be doing is being able to keep a second camera fully in sync. So we're going to have it that we can manually specify which camera. Now, reality is that's probably always going to be the main, so camera.main, but we'll just link it up so that we can easily be controlling it if we need to. So that's good. And we then need to have tracking of, well, what are the different worlds? So we could have this where we have a single pair of worlds. We could have multiple sets of ones. I'm going to set it up just for a pair of worlds. It's something that we could then extend it to further ones, but that's something where we would only really want to be able to be peering into one world at a time. We want to limit how many other cameras we're driving. So we need a way of keeping track of the different worlds. So we would have a transform for world 1 reference and a serialized field, they transform for a world 2, maybe anchor is actually a better term for it. So the idea is there needs to be some point that we can use as our anchor in each world. Now, that's something that's going to be really important. What I will do is we can just use the actual world objects itself. So that's our anchor. And we have our tracked player and our camera. We don't want the Cinemachine camera on the player. We want to use our main camera here. So what I want to do is just be tracking and working out, okay, which world and things we're in. So I need to have some sense of that. So E, current world, or E world. We could have world 1, world 2. And then what we want to do is track our initial world. So that's a useful thing to also have. So our E world, initial world. Well, we're going to default to world 1. So that looks good. We could also set that as current world, except I don't want other things to be able to change that. So what I can do, I can make that get and private set, but then I couldn't change that in the inspector, except I can, if I do this field, serialize field. So this, when I do like of this and create this property, there's a hidden variable, a backing field that gets created. So if I do this, that says, hey, to the backing field, apply this attribute. So what I'll find is I can see in the Reality Manager that current world setting. Okay, so that gives me enough that I should now be able to be continually tracking and seeing where the player is. So, okay, what I would do is F current world, and that would be, you know, I could check, okay, if the current world is world 1, then the player offset would end up being relative to that world 1 anchor. So we'd have player offset is the tracked player transform position minus world 1 anchor transform position. Otherwise, we would use the the world 2 anchor. What could be handy is having just a little property here where I can just go, cool, current anchor, and then if current world is equal to world 1, then we just do that. That simplifies my code down here, where it just becomes, well, player offset is tracked player dot transform position minus current anchor. So it makes it a little bit easier for us sort of keeping track of these things. I could go a step further and I could go for anchor position and then change these so they just actually return position, and that'll simplify this even further. So always good to use sort of little properties, expressions like this to simplify the code that we're writing. Again, simpler code, always better. So player offset, that also then means that I can work out the new location. So we'll actually change that to current anchor position, because then I can work out, I could have vector 3 other anchor position, and I can use this, but then what I will actually do is just flip these. So if it's world 1, we use world 2. So again, makes it easier down here. I'm not needing to constantly do checking of things. So I could then work out new player location, well, shadow player location, ends up being player offset plus other anchor position. So that looks good. And what I could do is, just for now, debug log that new player location. Now, with how I've positioned these worlds, world 1 is 50 units above world 2. Now, they don't need to be. That's just something I did for ease of setting up. But we can see I've got the player location up here, and the other location is exactly 50 below that. So as I move, it's lining up perfectly. So we've got that sense of the location that it would need to be going to. So now we can actually move that shadow player. So we're going to create a shadow player that we actually move around and keep track of. So the shadow player, that's going to need to be a game object. So what I will do is I'm going to create an empty here, and this will be shadow player. And then I will also actually have a shadow player camera. Now I'm not going to do anything with that just yet. And actually that I will end up creating it as another camera. So shadow player camera. And we won't do anything with that yet. We need to make sure we remove the audio listener, and I'll turn that camera off. So we don't want it doing anything yet. So then the reality manager needs serialized field, needs to keep track of the shadow player, and also I will actually have it be the camera, shadow player camera. So what we end up doing down here is shadow player position becomes this. So we move the player. So update the shadow player location, which we can also do this in just a single line if we want. It can be even simpler. So that looks good. We can just do it like that. We could also permanently calculate that delta and simplify it even further, but this works. So updated the shadow player location, update the shadow player camera location. So shadow player camera, its position. So it's transform position. We can set that to, well, we already have our tracked player camera. So we would have tracked player camera, and then we apply the same setup. Let's transform position. So okay, that's going to mean the shadow player, its camera gets updated. I also want to update things like the rotation. So it's transform, and we'll update it so it's rotation. Now in this case, we just set it to be exactly the tracked rotation. Same for the shadow player here. Its rotation is just set to exactly the tracked rotation. So track player, transform rotation. So now we should have something that is moving consistently and facing exactly where the other one would be. So we can keep an eye on that, and we expect to see our shadow player get moved. Now we didn't link the shadow player up, so we'll just connect those up. And then if we watch, our shadow player should move, and I'll move the game view here. And because I've got the shadow player selected, so as I look around, you can see the shadow player is moving. As I move, it's changing. So if I'm here looking at this, if I jump, so all of that is updating. So that's good. We've got something where we have that movement and everything synced. So, okay, let's have it for being able to flip between the worlds. So we'll make this public void flip worlds, and there will need to be a safety check. For now, we won't do that safety check. So there'll be a to-do safety check. What we'll initially do is we need to make it be pretty much moving instantaneously. So what's going to happen is the tracked player, their information gets synced to the shadow player. So tracked player, and we only need to update their position, ends up being the shadow player transform position. And then what we need to do is the current world, well, if current world is equal to world 1, then it becomes world 2, otherwise goes to world 1, and we should then do a synchronize. So I'm going to synchronize reality or synchronize shadow player. So I'm going to move all of this into a synchronize for the shadow, just so that when we do the flipping, we can make sure it's up to date immediately. So we've updated the position, we've updated the world, and then we can do synchronize shadow. So what I'm expecting then to be able to do is, if I look on the player, we do have a couple of things there for some simple interactions. We don't have something that'll currently kick into the reality manager yet. So what I can do is if I go, and what I will actually set up is in our input for the player. So we've got our controller here, and I'm going to add in a new action that'll be similar. We could use the secondary action for this actually, so the right mouse button would work. So we'll go to the character motor, and we'll set up so we have Unity event, and we'll add in a using Unity engine.events, and we'll have on secondary action, and I'll just invoke that down here. So we've already got that. Perform secondary or on secondary, just so the names don't collide. So with on secondary, we'll say F input secondary action. We invoke that. That'll just make it easy for us to connect this up to the world flipping. So then down here, once that loads, we'll be able to go, okay, well, on secondary, I want you to talk to the reality manager, and I want you to do flip worlds. So now, when I do the secondary action, I should find that I am no longer in this world, but in another. So I'll move over to here, and I have changed. And it's instantaneous, but I can just flip really rapidly between different ones. But that does mean I can end up potentially inside objects. So that's something we do need to make sure we fix. We don't want to have it that we are ending up inside other objects like of that. So let's get the filtering so we're not going into other objects setup. Okay, so the safety check is a pretty important part. So the way we're going to go about doing that is we're going to use a physics check capsule. So that's going to find any colliders that are overlapping with the capsule for the character. So, okay, for that we need to give it start positions and end position and radius, so we can calculate those. So the start position, when we're doing check capsule, what it does is it has a sphere at the start and the end and sweeps in between. So our start position, well, we take our shadow player's position, but we need to actually offset that because it needs to be placed that radius of the sphere off of the ground. So we need to add our tracked players transform up, multiplied, and we need to get the player's radius. So I've added in here into the character motor a current radius. So we can go tracked player current radius. And I'm going to put this just down here on another line. Now that would result in something that would intersect potentially exactly with the ground. So there'd be no margin of error there. So, and I'll move this up to the top in a moment. I want to actually have a safety check height buffer. So just a tiny little buffer that it adds to this, so that allowing for some slight offsets in positioning, things like of that. So that's good for our start position. Our end position, well, that is going to be our start position plus, well, it's again going to be something that is tracked player dot transform dot up multiplied by, well, we can get their height. So we can get the tracked player, now we can get the current height. And what we could then also do is, because this is going to be the range that it sweeps, so we have to actually take a little bit of a distance off for that radius as well. So the current height minus 2 times the tracked player current radius. That's good. We also want to have a layer mask so we can say what things it should be checking against. So layer mask, safety check mask. I'll default it to everything. So then I can do my check capsule and I give it a start position, end position. I give it the tracked player's radius. I can give it the safety check mask. So this will return true if it actually overlaps with anything. Does the capsule overlap? If it does, I'm going to return. I also, and I'll move these settings up, I want to make it that I can fire off an event when that happens, just as a way of being able to signal, hey, something's gone wrong. So I'm going to bring in Unity Engine.events, and I will set up a serialized field, Unity event, on failed flip, or on failed to flip. That way, just if we wanted to have something particularly happen, some other indication, we've got that. So on failed to flip, invoke. So let's just test this out. This should mean that it's not able to transition when it would be inside an object. So let's see if that's working the way we want. We do want to update this mask. Pretty much anything other than water. And the default we don't want to check. So I'm in a clear area now. I can safely flip. Let's head over to where this box is. You can see I can't flip, so that's good. Got a smaller box here. Again, that's preventing me from flipping. What if I'm crouched? See, if I'm crouched, I have to wait till I'm outside of it. So that's good. We've got the ability to now flip between the ones and check that we are safely able to do that So good so far. Let's now get it that we can see into the other world, because that's going to be a cool element to add to it. So now with how this is going to work is what we're going to have is we've got our second camera here, and the second camera is going to be drawing to a render texture. And then the player is going to have an object that there'll be a custom shader on it that it will just, when it renders that object, it grabs whatever was in the render texture. So essentially grabbing what screen we would see in the other world is, and just overlapping that onto our object, which allows us to use any shape of object for it, which is really handy. So what I can do is I'm going to go and create a 3D object here, and I'm going to make it a sphere. We'll definitely get rid of the collider because that would otherwise work very, very poorly. And we're just going to move this. So I'll put it at about there. I can probably reduce this size even further, to be honest. And this is essentially, this sphere is going to allow us to peer into the other world. And I might lower the height of that just a little bit. So view, let's call it looking glass. So it's going to have a custom texture on it, or custom material. So we'll have a material, and we'll just set that up. Material, other world, or looking glass could work. So looking glass, put that on the object. And then we need a custom shader. So I'm going to create a standard surface shader. And this is going to be the looking glass shader. Put that into its own folder as well. And that looks good. So we're going to set the shader up in a moment. The first thing we want to do is we want to make sure that the camera is working. So I'm going to start setting it up so it's synchronizing the camera settings over, because that's something we're going to need. Because we've synchronized the shadow, there's a lot of camera settings that need to transfer over as well. So shadow player camera, its field of view has to be the same as the tracked player's one. We also want to bring over, if we look at other settings, so anything like clip planes, we should bring over. Would be the far clip plane as well. So we want it to match exactly. So the other thing we can do is the background color. We set that. And we can take a look and see for any other settings that we might want to actually change. So we could potentially bring over some of the other settings there as well. Clear flags is definitely one that we should transfer over. That looks good. Update the camera settings. So to make sure the camera settings just always match. That's really going to be important. So the reality manager now is going to need the render texture and to update that. So I'm going to have a render texture, and this will be our looking glass render texture. And I'm going to set up a function here, set up render texture. The reason being is that if we did something where we changed the resolution, we would need to reset that texture up. So we'll have set up render texture. And what I'm going to then do is, well, looking glass, that is a new render texture. We use the screen width, the screen height. We don't need a depth buffer, so I'll have that as 0. We do want it to just be the full setup. We don't need to set up any of the other settings. But we've created that render texture. What we can then do is the shadow player camera, its render texture, so its target texture we can set is going to be that. So that means that texture will be properly updated, which will be good. Now the other thing that I'm going to do is I'm going to turn this camera back on, and then I'm going to adjust the depth so that it's not the main one being shown. So that looks good. It will be rendering things from that other scene. There might be stuff that we do then also want to cull. That's something to be aware of. We might have different culling flags for the other environment, which we could definitely do. But that looks good so far. Our material, we can switch that over to the Looking Glass shader. So with that updated, what we would expect to see is the texture gets created, and we can see that it is using this. Now, as I look around, now this won't automatically update. I would need to each time go and select to force it to refresh, but it is picking up the information, which is good. So, okay, we've got that data coming through. We need to now get our texture, the render texture, to the material. So a couple of ways we could go about doing that. One of the things we could do is in the Reality Manager, we could give this a mesh renderer, and we could give it the particular sort of mesh. So we could have that, so we could pass it through that way. That is absolutely a viable way of doing it. Ends up being a lot of interdependencies we set up though. We also have another approach where we can directly inject the shader or the texture to it. So that's the way that I'll actually set it up. So it has it a little bit more decoupled. So we're not needing to do any hard links to the player. Usually try and where I can avoid hard links to the player. Now we do already have some, but these are ones that I would absolutely be able to find via discovery. So that's something where I want to try and minimize going too deep with those links. This is a little bit, but ones that we can already retrieve quite easily. Something where it's just a generic mesh that's sitting on the player, that's a bit of a more sort of finicky one for retrieving. So what I'm going to use for passing this over is a similar approach I've used for other ones where I need to shuttle textures around. So I'm going to have one, this ends up being a Looking Glass copy, or a Looking Glass texture we might just call this. So whenever we update this, whenever we set up that render texture, I want to set up Looking Glass texture, and that's just going to be a new texture 2D. I'm going to just pull everything from the render texture here. Strictly speaking, I could go and grab it again from the screen, but just to avoid if something went wrong and I messed up the settings, it means that it's going to be synced exactly to that texture. So the render texture is a graphics format, and we then have to specify the everlong creation flags. So that creates that texture. Then in update, what I do is I can transfer this texture over. So update the Looking Glass texture. So do a graphics copy texture, which I can copy from the render texture to that. And then I can do a shader, set global texture. And I can say Looking Glass text is our Looking Glass texture. So this is a really handy thing, being able to set global stuff. It means that that's then available to every single shader, which is really handy. Now I'm going to get rid of the albedo there. The main texture here we don't need, so I'm going to remove that. Our input, I need the screen position. Now the naming of this matters. I have to make sure the case and everything matters, and it is a float 4. So we need to make sure our screen position comes through. So with that, we then down here, I need to set up for my texture, which I called Looking Glass Text. So I have a uniform, and this is a sampler 2D, which the name for that is exactly what I use for the set global. Then I also have a float 4, and with this we add the suffix of _st. It's just a naming convention that's expected. Then when I go and sample stuff, well, I'm sampling rather than from main texture. I use the Looking Glass texture, and then I use in, and I use screenpos.xy divided by screenpos.w. That will give me the actual screen location. So what I'm doing is I am capturing the screen as if I was standing in the other world. Then when I render this particular object, I just take, rather than sampling the object's UVs, I get the location on the screen of the pixel that it's drawing, and I grab that corresponding pixel from the texture I already picked up, which means that my looking glass can be any shape and it will just work, which is really powerful. So this should, with that set up, let's now test this. So you'll notice the floor changes color there, and like these boxes are aligning perfectly, which they should because there's nothing different. But I look over here and I can see this other box. So that gives us a really, really powerful way of working with this. Now, one of the things we do want to check on is, okay, what does this do to performance? So if I turn this on, what are we looking at frame rate wise? Now it's a very simple environment. We're seeing pretty decent frame rate still, so not a major impact, but that is something where we might need to do stuff where we're managing the rate that it's updating at, things like of that. So that looks pretty good. As a final thing to add to this, I want to make sure that I have got the post-processing in, and let's make it that we've got slightly different post-processing for each world, so it sort of feels like a different world. Now the setup that I'm using here, I've done this in built-in pipeline. There is nothing that would prevent this being used in any of the other pipelines. So the same process, you could use this with high definition or your universal pipeline. It'll work with those without any issue whatsoever. So once this is imported, we'll just set up 2 separate volumes. And because it's going to be tied to where the main camera and so forth is located, those should correctly pick up the right volumes, and so we should see the correct versions of things. So it takes a little bit for it to import it, and then we'll be ready to set it up. Okay, so what I need to do is, first thing, is I need my volumes. So I am going to add in a 3D object, and I'm going to add in a post-process volume. And I'm going to set up one in world 1 and one in world 2. So this will be world 1 EPV and world 2 EPV. Each one I want it to have its own profile. So I can just do new in each case. Now, these aren't global. What I am going to do is set up a layer called post-processing. Make sure these volumes are in that layer. And then I just want to get the sizing of these correct. So if we go up to each one of these and relative size wise, I want the positions to be 0 like that. Scales, I'm going to just set them to 1. You see that's now encompassing a large chunk of it. So the collider for this, I can update its size and also offset it a bit. Might give it a bit more height than that. So that should give us different post-processing volumes for each one, which we've got. That's good. Then our camera, we need to make it that our cameras are actually, well, our main camera is actually looking up the post-processing volume that it's within. So we add post-process layer, and we tell it we want you to look at the post-processing layer. A shadow player camera can get the exact same thing because it is a full camera. So again, layer becomes the post-processing. So then we can configure what these look like. So for world 1, let's add in few effects. What I will do is world 1, I might can do some color grading. So the saturation in world 1, I might, just to make it really easy to tell it, I will desaturate it, and color filter, we can probably tint it so it's a little bit sort of sepia toned. So that's good. Whereas world 2, well, we're not in world 2 at the moment, but what I can do is once it's up and running, I can easily configure that. So what I should find, because that looks good, I flip different post-processing. But you'll notice when I'm peering into the other world, I see the post-processed version for it. Now I can go and update the effects here. So we can go and easily update this. So what I could do is for an effect here, let's add in a color grading on this one as well. But what I'm going to do is ramp up the saturations. This one's really bright. And could also add in bloom if I wanted. Make it that it's really sort of bright looking. So that looks pretty good. So now when I switch between these different ones, we'll have post-processing changing as well. And we can see we do pick up on that bloom from the other one. Then we're over here. We see the different version of the environment. You know, I can't walk through that. And same when I get back here. I can't switch world because I'm inside the TV. We've got our world flipping happening. So we've got the ability to track where we are in those worlds, to move between them. We have the ability to make sure that we're not hitting into something when we go into a transition, and we can peer into those other worlds. So that gives us something that works really effectively. And those transitions, we don't need to be stationary for it. We can, as I'm jumping around, switch between different environments. So we have that ability to just switch at any point in time because of how we are doing the drawing of the other world through that looking glass. Our looking glass there can be any shape whatsoever. It's just we then only the surface that we need to do we apply our material that says, yep, show me the other world through this material. So it gives us something that's really easy and flexible to work with there. Thanks, folks. Hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. Really helps out. It's really appreciated. If you're looking for the code for the project, it is available up on GitHub, and there is a link to that in the description below. There is also a link to the video archive, which is a searchable archive of all of the videos. You can search based upon the descriptions and keywords there. And if you've got any questions, chuck in a comment below. If you're looking for other ways to support the channel, I do have a Patreon, and there's also a link to that in the description below as well. But until next time, bye!